Calculate the work required to pump all of the water out of the full tank. Distances are in meter and the density of water is 1000 kg per cubic meter. We will set up the Riemann sum for the work. Take the limits to obtain the definite integral. But first, we will need to draw a diagram. There are many ways to choose the coordinate. I will set up using the origin at the center of the circle. This is a semicircle. The radius is 10, and if we were to put the origin at the center of the circle, then the equation of this circle is x squared plus y squared equals 10 squared. To find the work, we will find the work of one representative slice. The work to bring the ice slice to the top 2 meters above the water surface is the force times the distance. The force is the mass times the acceleration, which is the gravity, times the distance. The mass for the ice slice is the volume times the density, but the volume is the area times the thickness, which is delta y. And the slice is in a circular shape, and so the area is pi r squared. R is the radius of this circular slice. The thickness is delta y. The density is 1000 kg per cubic meters. The gravity is 9.8 meter per second squared. And the distance that the slice needs to travel is 2 minus y. It is the vertical distance that the slice would need to travel all the way to the top. At the top, the height is 2 meters above the water surface. And so the distance from yi to 2 is the upper minus the lower. The upper y is 2 and the lower y is yi. It remains to rewrite the radius r in terms of y. But the relationship between x, y, and r can be seen in the right triangle, whose hypotenuse is the radius 10. At this point, it is x comma y as the coordinate, and so the horizontal distance is x and the vertical distance is y. The horizontal distance x is the radius of the slice, and so the radius is x, but x squared plus y squared is 10 squared, and so x is the square root of 10 squared minus y squared. But we need an expression for r squared, not r. Thus, r squared is x squared, but x squared is 10 squared, which is 100 minus y squared. Thus, the work at the ice slice is 1000 times 9.8, which is 9800 pi. R squared is now 100 minus yi squared. Distance is 2 minus yi, and the thickness is delta y. The total work is the sum of the wi. Each of the wi is 9800 pi times 100 minus yi squared times 2 minus yi delta y at I go from 1 to n. As n go to infinity, we obtain the definite integral from this Riemann sum. 9800 is a constant multiple, we can also move 9800 pi to the front of the integral sign. 100 minus y squared, we could drop the subscript I, times 2 minus y. Delta y becomes dy. We need to add up all of the slices from y equals 0 to y equals 10 only, even though for the distance we would need to bump the slices all the way to y equals 2, but that is why the distance was 2 minus y. The slices of water, the water only lies between y equals negative 10, which is the lower limit of integration, all the way to y equals 0. To evaluate this integral, we should distribute to obtain 200 minus 100y minus 2y squared plus y cubed dy, and find the antiderivative. If we were to integrate this, we should get 112,700,000 over 3 pi, or in decimal, this is roughly 118,019,164.02. The unit is joules.